Exercise 3.2, question number 2. Find the polynomial equation of minimum degree with rational coefficients having 2 plus root 3i as root. So before getting into the solution, we are going to see a theorem. Theorem 3.3. And what theorem 3.3 says? Let p and q be the rational numbers such that root 3 is irrational. You know what is irrational? P plus root q is a root of quadratic equation with rational coefficients. Then p minus root q is also a root of the same equation. So simply I'll say if p plus root q is an equation, it's a root, then p minus root q is also a root. So using this particular theorem, we are going to do this sum. Now solution, 2 plus root 3i is a root. So from the theorem 3.3, we can say that 2 minus root 3i is also a root. So taking this as alpha and this root as beta, we are going to frame a quadratic equation. Sigma 1 is nothing but alpha plus beta. So 2 plus root 3i plus 2 minus root 3i. So cancelling these two terms, 2 plus 2 is equal to 4. And sigma 2 is equal to alpha into beta, which is equal to 2 plus root 3i into 2 minus root 3i. So a plus b into a minus b, which is a square minus b square. So 2 square minus root 3i the whole square. So 2 square is 4. Root 3i square is 3 into I square. You know that I square is minus 1. So minus 1. So finally we have got 7. Now the required equation is x square minus sigma 1x plus sigma 2, which is equal to 0. So x square, sigma 1 is 4, so minus 4x, and sigma 2 is 7, so plus 7, which is equal to 0, which is the required equation. Now exercise 3.2, question number 3. Find a polynomial equation of minimum degree with rational coefficients having 2y plus 3 as root. Now we are going to see a theorem, then we are going to solve this problem. Theorem 3.2, complex conjugate root theorem. It says if z0 is a root of a polynomial equation, then its complex conjugate is also a root. I'll say with an example. That theorem says that if 3 plus 2y is a root, conjugate of this number, conjugate is nothing but change the sign, right? So it is 3 minus 2y, it is also a root. Okay, using that only we are going to do this problem. So here 2y plus 3, I have written that as 3a plus 2y. So conjugate of this term is 3 minus 2y, right? So similarly, taking alpha as one root and beta as another root, I am going to do it. And sigma 1 is nothing but alpha plus beta. So 3 plus 2y plus 3 minus 2y, which is equal to 6. Cancelling these two terms, 3 plus 3 is 6. And sigma 2 is equal to alpha into beta. So product of the two terms, a plus b into a minus b, a square minus b square, which is 3 square minus 2i the whole square. 3 square is 9 and 2i square is 4i square. I square is minus 1. So 9 minus 4 into minus 1, 9 plus 4 is equal to 13. Now the required equation is x square minus sigma 1x plus sigma 2 is equal to 0, where sigma 1 is 6 and sigma 2 is 13. So x square minus 6x plus 13 is equal to 0, which is the required equation. Thank you.